Start reviewing. You guys getting ready to wrap this semester up? It's going to be a happy ending, right? They all lived happily ever after. They went on happily to their higher level math classes. All right, here we go. So we're trying to find an inverse function. How do you find an inverse function? Remember we covered a section earlier on inverse functions. So, we're doing inverse trig here, but in general, any inverse function, what are the steps for finding an inverse function? Switch x and y, solve for y. So step one, switch x and y. Step two, solve for y. Right? Those are the two steps. Good little review. Final exam's coming. When is our final? It's 2 weeks from today. 2 weeks from today. Final exam. So, inverse functions. All right, so here we go. F of x is y, isn't it? That's basically y. So the first thing I'm going to do is switch x and y. The y will go where x is. The x will go where y is. So my first step, I will have x equals minus 2 cosine 3y. Is that making sense? I switched x and y. So there's step one. Now, y is over here saying, I want to be alone. I want to be alone. So it's like peeling an onion, isn't it? To get y alone, which is right here, we're going to start on the outer layer, get rid of that negative 2, get rid of that cosine, then finally get rid of that 3, and y will be alone. Start from the outer layer and work down like peeling an onion until you get y alone. So first step, got to get rid of that negative 2. So that's just divide, huh? Because that negative 2 is just multiplied. So then that's, what is that? That's x over negative 2, these are gone, is cosine 3y. So far so good. Now I remember we talked about this last time, and I said you don't divide by the cosine, right? I remember us talking about that. Yeah. So that's the mistake a lot of people make. Y'all are good to not do that now, right? We don't divide. Why can't I just, to get rid of the cosine, why can't I just divide both sides by cosine? Why is that so wrong?
Toaster. It's not a division.
Toaster, right? Because it's not multiplication, so you can't get rid of it by division. Exactly. This does not mean cosine times 3y. It means 3y is plugged into the toaster. That's right. That's why I started all the toaster talk. Because I realized students weren't realizing things are plugged in. They're not just sitting next to it. That 3y is plugged in to the cosine, huh? So instead of, you can't just divide because that's not multiplication. That's like f of 3y or something, huh? It's a function. It's plugged in. So is log. If that was log of 3y, that's also not multiplication. That's plugged into the log function. All those things are functions. They're plugged into the toaster. They're not just sitting next to it being multiplied, right? If they were, you could divide, but they're not. They're not just multiplied. So, well, then what do you do then? If you can't do that, how do you got to get rid of the cosine somehow. If we can't divide by it because it's not multiplied, well, then how do we get rid of the cosine? How do you get rid of something plugged in? You do the inverse function. That's why we have an inverse logarithm. That's why we have an inverse cosine. That's why we have inverse functions. Because that's the only way to get something out of the toaster, is you've got to do the inverse. So I'm going to go over here and go, okay, inverse, I don't really have room here. Inverse cosine on both sides. You got to do the same thing to both sides, right? I'm going to do inverse cosine on both sides, and it cancels there. So then that's inverse cosine of x over minus 2 is 3y. So everybody see what happened there. I did inverse cosine on both sides. And it canceled. That's why we have inverse functions. Right? That's how we get stuff out of the toaster, is we do the inverse function. All right, so what does that leave us? Bring it over here. That gives us cosine inverse of x over minus 2 is 3y. Now it's easy. Last step to get y alone, just divide by that 3, because that one is just multiplied. And there we go. There's the inverse function. Oh, by the way, multiple choice test, you all know that's the same thing as a 1/3 sitting. If they write it that way, that's okay too, right? That's another way to say the same thing, isn't it? 1/3 in the front, or a big old divide by 3. Same thing either way. Inverse function. Good? They're also, by the way, excuse me, asking me for the range and domain and stuff like that. They want the range of f and the domain and range of f inverse. So let's get that. Let me go, if you've got that copied down, I'll go to a fresh screen here. And we'll answer those questions. So I have, what do I have? I already forgot. So y equals, so the inverse, write it over here. The inverse function then is, what is it? 1/3 cosine, oh, that's cosine inverse, isn't it? Cosine inverse there. Cosine inverse, 1/3 cosine inverse, x over -2. Okay, so there's the inverse function. And here's the original function. Now, what are they asking me for? They want the range of the original function. The range of this, the original function, right? Range of f first. Any ideas? Think about the graph with me for a second. What if you were going to graph that? We just had the graphing section, homework just last night, huh? If you were going to graph this, it would be cosine. What would that -2 in the front do? Yeah, it'd be down at -2, and then it would do its thing, and it would go up to +2, huh? Remember, range is just the up and down. So the range is just -2 to +2, isn't it? So the range, the range of f, bless you, was -2 to +2. See how I did that? Just because I know about the graph. Right? We know about the graph. The graph of cosine with a -2 in the front, that means it goes down to -2, up to +2. That's the amplitude. So we know the vertical coverage, the range, is -2 to +2. What else do they want? The domain and range of the inverse. Remember the connection between inverse functions and the original functions? The range of f is the same as the what of f inverse. The range of f is the same as the what of the inverse function. Domain, huh? I was expecting with one voice in chorus, you would all say. Remember they switch? Domain and range switch because x and y switch, huh? Domain is x, range is y, range is up, down, x is domain, sideways. So domain and range switch. So range of f is domain of the inverse, and vice versa. So if they're asking me for the domain of f inverse, which they are, well, that's going to be the same. -2, +2. Finally, last thing they want is range of f inverse. So now how do we find the range of f inverse? Well, it's going to be the same as what? The domain of f. Right, so domain and range switch for regular function, inverse function. You with me? So range of f is the same as domain of f inverse, and range of f inverse is the same as domain of regular f. So what? Well, do I know the domain of regular f somehow? Yeah. What is domain? X or y? X, right? Domain is x. Range is right. See how range is up, down here? Range is y. Range is up, down. Domain is x. X. Do I know anything about x for the regular function? Do I know anything about x for the regular function? They're handing it to me, silver platter. There it is, right? For the regular function f, they're telling me let x be in that zone. They're giving me a limited domain. They're just handing it to me. They're going, here it is. See that? It's just sitting right there. So it's just what? 0 to pi over 3. See what that's between 0 and pi over 3, right? So that is also the range of f inverse, and we're done. Do you all see that? How we made that connection? Anything I can say to help with that? Is that good? Shall we try one of those? Okay, so let's try that one. Really, you don't need to do anything with all this stuff until the end, when they ask you about domain and range. Because really, this is just a condition on x, isn't it? It's a domain for f. Thus, it's also a range for the inverse. Anyway, whatever. Ignore it for now. Here's all we need for now. Can you take that function and find the inverse? Let's just start with that. Can you find the inverse? Give you a second. Try that. So the F is the Y, huh? Like that. And then what do we do first to find the inverse function? Switch the X and the Y, and then solve for the Y. Good there. Like that. So switch them, and then solve for. I'll give you a second. Feel free to check. I'll wander around so that can be helpful. We have a little bit of time to slow down a little bit.
6
Yeah, 5 emergency.
Isn't that 5y though?
Huh?
Isn't that 5y?
Yeah. 6 3 divided by 5.
Oh, okay.
This 6 put it here.
I think you can move it.
I can.
Yeah.
Yeah, it's a negative and it's 1.
Or you could just put the whole thing over 3, but I don't know. Does that make sense?
I'm now trying to take out the sign. The 6 goes with the y. Yes. When you add it.
I kept it out.
No, you kept it out.
Because it's. I don't think so. Unless you want to do a common denominator and get them all in one fraction.
Oh yeah. No, I'm not going to do that.
Really complicated, but I think sine inverse 6 plus x over 5, and then we divide the 5 with y.
That goes away.
Cross out the 5, right?
Yeah.
So it would be just sine inverse negative 1. I mean sine inverse plus 6 x. 6x? Or 6 plus.
Good. So divide by that 5, like that. So we're trying to get the y alone. Our plan is to get the y alone. And so where does that leave us? X over 5 is sine of 5y minus 6. So the two steps again. Step number 1, switch to find an inverse. Switch x and y, which is what I did right there. And step 2, solve for y. So I'm working to get y alone now. It's like there's a wall here, and y is saying, I want to be all alone over here, get rid of everything else. Everybody tracking with me on that? So I gotta get alone. So I start by getting rid of the 5, and that's divide both sides by 5. And then you got to get rid of the sign, which again, that's not multiply. It's inverse, so we get rid of the sign by doing inverse sign on both sides. So let's do that. So inverse sign, boom, that cancels that out, doesn't it? Whereas, but the left side, it stays. You all see why it cancels out on the right side but stays on the left? Because on the right side, you have both a sine inverse and a sine. So it's like a poison and an antidote or something. They just neutralize each other. They're both gone. Left side, it's going to stay if there's only one of them. So what do we have then? I'm going to bring it up here. We have sine inverse of x over 5. And the right side now is just 5y minus 6 because the sine and sine inverse are gone. Okay, we're supposed to get y alone. So what are we going to do? Add 6 to both sides. So we get, let me get this out of the way here. We now have sine inverse of x over 5 plus 6 is 5y. These guys canceled. Is 5y. Okay, and now last step to finish getting y alone. Divide by 5. You can just divide the whole thing by 5, or you can divide each one separately by 5. That's the same either way. You okay with that? Like on an exam, a multiple choice? You put the big old 5 like that. That's fine. Or you could say, I'm going to put a 1/5 in front of this one, and a 1/5 here would make that one 6/5. That's okay too. Both are right. Two ways of saying the same thing.
You can't.
Which 5s?
X over.
Like these 5s? Yeah, no, this one's in the toaster. It's like in a different world. It's plugged in, and yeah, we can't do that. You're right on that. It's x over 5. Other questions? Yeah.
So say if you like didn't want to apply 1/5 to everything, you just put 1/5 and then put the
Parentheses or?
yeah parentheses from the inverse.
Yeah, you totally could. Yeah, you could just take, instead of doing the 5, you could put a 1/5 and a big old parenthesis. That's the same answer too. That's another way of saying the same thing also. Yep. Good. Other questions on that? That okay with the solving there? For the inverse function? Okay, so and then they want you to do the domain and the range thing. So let me go to a fresh screen and we'll see if we can nail that down. So we have the original function here. Here's that statement about x. When they make that statement about x, that's really the domain, isn't it? Of f, because it's f, and it's talking about the x values, which is domain. And then over here we have the inverse function. What was the inverse function? It was, I already forgot. 1/5 sine inverse, okay. Plus 6/5. Okay, so we have the original function and the inverse function. Now, first thing they want to know is they want to know the range of f. Let me give you a second. See if you can find the range of f. So what's the range of f? Yeah, because that 5 in the front, just imagine if you're graphing, remember we did the graphing homework yesterday. If you were to graph that, that'd be the sine function. He starts at 0, but that 5 does tell you how high and how low he's going to go. Remember that? Remember that's the amplitude? That's the high, top and the bottom, right? So that sine graph, this f graph, is going to go to a height of 5 and a depth of -5. So that is his range. Range is the up, down, the vertical coverage. But you got to put the lower one first. You got to put -5 first. You got to put the bottom first, then the top. It's going from lowest to highest. So that'd be the range, -5 to +5. And if that's the range of f, what is that also? Domain of the inverse, huh? So that would be, bring that on over. That's the range of f. which is the domain, it's the same as the domain of F inverse. So the domain of F inverse, bless you, is the same exact thing. We got that. So then finally, the last thing they want from us, they're asking me for the range of F, we got that, and want the domain and the range of F inverse. Well, I've got the domain of F inverse. How am I going to find the range of F inverse?
Isn't it just the domain of F is there?
Yeah, it's this, isn't it? It's the same as the domain of the original function, which is what? Now, how do you do this? Well, that would be a bracket again, and it would be 6/5 minus pi over 10, comma, 6/5 plus pi over 10. Yeah.
Could you just write that as one fraction, so it's 12 minus pi over 10, 12 plus pi over 10?
Yeah, that'll work. Get common denominator. Yep. That's good too. And we're done with that one. All's well on that? Questions I can answer? Finding inverse functions? Domains and ranges? All right, what else is... So it says 3 cosine inverse 5x is pi. Yeah, they want me to solve for x there. X is over here saying, I want to be alone. So let me let you try that. Can you get x alone? It's peeling the onion again. You know what I mean? Start in the outer edge. Get rid of the 3. Get rid of the cosine inverse. Get rid of the 5. So peel the onion. Get the x alone there. First step's going to be divide by that 3, right? Get rid of that 3. First step's get rid of that 3. Good to there. What? Now we're trying to get that x alone. Remember the goal. X is saying I want to be alone. So get rid of this cosine inverse. Get rid of this 5 so I can be alone. So next layer cosine inverse. How do we get rid of that cosine inverse?
Cosine.
Regular cosine, right? It's you do the cosine of. So it's not multiply. It's cosine of both sides, right? It's plug into the toaster. So then these cancel each other out. You always do the opposite, don't you? That's how we get rid of a function. Do the opposite. So then we get 5x is cosine of pi over 3. And cosine of pi over 3, we can actually get a number on our calculator. Well, or on our unit circle. Go grab that unit circle. Pi over 3. There it is, pi over 3. Cosine sine. Cosine's a half, huh? See it right there? You have that unit circle on your chart, your 3x5 card for the test. So, for the final, this is something on the final. Cosine's a half, so that cosine's a half. We good to there? Last step, we got to solve for x. Divide by 5, but instead of dividing by 5, since the other side's a fraction, why don't I just multiply by 1/5? That'd be quicker and easier. X would be 1/10, and we're done.
So whenever we divide cosine or cosine inverse, that wherever they go, they become a function of their own. Like when you divided cosine inverse by cosine.
Okay, what's confusing me is the word divide. Where did I divide?
Well, when you cross out.
Oh, okay, when you cancel, okay.
When you cancel, does that become a function? Well, like whenever you do that?
So right here, I'm taking the cosine of the cosine inverse.
Right. Yeah.
Right. So they're opposites.
Right.
So yeah, so they eliminate each other out.
But on the other side, it becomes a new function.
Yeah, well I did it, I had to do it to both sides.
Yeah, and that always happens. Like.
Yeah, so, right, so right here I did cosine and cosine on both sides. You know, whenever we do something, we have to do it to both sides.
Yeah.
Right, so I'm just doing cosine on both, yeah, so it's a good question. I'm just doing cosine on both sides. And on the left side, they cancel out because there's cosine and cosine inverse. But on the right side, yeah, it stays as a function. It does. That's how it always works, yeah. That's right. That's good. You know what that's like? I don't want that to seem, I think I could do you more good if I tie that into something you already know. Remember all my Hitler talk, getting amount of part? That's what we were doing then. Do you know what I mean? Let me show you. Like, what if you had, what if we had 3 to the x is 10 or whatever, and you're trying to solve for x? How do you get rid of that? Well, that might seem confusing that way. What if you had e to the x? How about that? What if you had e to the x? How do you get rid of that? E is a function, really. I don't know if you think that way. But e, you're plugging into the e to something function. That's what you're doing. You're plugging x in. You can make this x plus 2 or whatever. That's plugged into the e function. Anyway, so how do you get rid of it? You do the inverse of the e function. What is the inverse of the e function? ln, yeah. But you do it to both sides. And these guys cancel, huh? That's the same thing. It's just the inverse function. That's the same thing as we're doing with cosine inverse. That's the idea. You getting that big idea in math? Whenever you have something plugged into a function, you got to bring the inverse a function. That's why we made logs, because they're the inverses of exponentials. That way they'll get rid of exponentials, and that's how we solve exponential equations, which occur in real life. So and then it would just be x plus 2. This is ln 10, whatever that is. Subtract 2, and there you go. X is ln 10 minus 2. Get the idea? That's how we deal with x plugged into any kind of function. So as you go into calculus, you'll be putting all these things together again and dealing with inverse. Make sure you're clear on that big idea. If you have something plugged into a function, you want to get rid of that function in the front, you do the inverse function on both sides. Gets rid of it. Good. All right. 7 cosine inverse x minus 4 pi. 7 cosine inverse x minus 4 pi is 3 cosine inverse x. All right, yeah.
Is the 4 pi like in the toaster with the x, or is it pi?
Oh, good question. It's outside. Yeah, if it was in the toaster, it'd be like that. Really good question. Really good distinction, huh? That 4 pi is outside. I'm glad you all are thinking that way about it. Yeah, be real clear. It's real important to know exactly that, whether it's in the toaster or out. It's out. Huh? That 4 pi is outside. Only if there was parentheses would it be in. Okay. So how do you solve for x here? Any ideas? Do you notice that these are big old fancy like terms? They're the same thing. There's 7 of these things, and there's 3 of these things. Yeah, subtract it, huh? Yeah, you can do it either way. Maybe I'll just subtract this one from both sides. Yeah, but it's big old like terms, isn't it? So these are gone. Minus 4 pi. 3 cosine inverses of x. Take away 7 cosine inverse of x is minus 4 cosine inverses of x. Good so far? Just combine like terms? Yeah. Well, the problem is it would go under the 4 pi also. So yeah, and again, it's not multiply. It is important that you're taking the cosine of, so it's not multiply. So you keep that in your mind, because then that will do a little bit different things. Yeah, I mean, it's not a bad thought. I don't think we could make it work well. Yeah, we can't. Yeah, I don't know if it's worth going into the long story. Yeah, I'll just say don't do that. It's kind of a long. Yeah, you can't. What it is? Now I want to tell it. I want to tell a story. So, because I don't like not explaining things. I guess that's why I'm a teacher. My family kids me because I over-explain things at home, and they'll be like, "Dad, we got it. Don't go on and on." My wife as well. I got it, honey. Got it. I'm like, well, but really, are you sure that I do? And I like explaining. All right. So that's a good question, because it's a good question. It makes me think. Why can't you? Why can't you just go cosine on this side, right? Cosine of that side and just go, hey, it cancels that. So that'd just be 7x, and the cosine goes right there, and then it's just 3, and it cancels that out. Well, there's a couple problems with that. You can't distribute cosine like multiplying. It's because it's not really multiplying. That's why I keep saying to y'all, I know it looks like multiplying with this parentheses. It's not multiplying, though. You got to realize it's not multiplying. So you can't distribute it like multiplying. Those kind of things I didn't really get till I was down the road in calculus. It's a lot of it takes practice. You got to, because it looks good, doesn't it? Boom, boom, there we go. But it's not multiplying. What do I mean? Let me show you a real. This would have helped me if teachers would have showed me a little bit more of a practical example. Think about 30 plus 60 for a minute. That's a cosine of 90. That's cosine of 90. What is the cosine of 90? Let's go back to the insert. Here's 90. Cosine, sine. Cosine 0, huh? So this equals 0. It's cosine of 90, huh? Do you see how it proves it's not right to distribute? Because then you would be saying, well, that's cosine of 30 plus cosine of 60. And cosine of 30, I don't even know what that is. Cosine of 30 is this, and cosine of 60 is that. They don't add up to 0, do they? See how it's just not right to distribute? That's not multiplication. So that's really why. If you're going to higher math, it's good if you can kind of solidify that in your mind. This is not times. So you can't just go to both of them like that. This example proves it, huh? That's the kind of stuff I didn't realize it. When I was a pre-calc student, I did not know that. I would have done that. I would have just distributed it right on across and been all happy. And looked in the back of the book and wondered why it wasn't right. I didn't know those kind of things. So, all right, good question. So back to this. So that's why we have to just like terms. And now how do we get the cosine alone? Next. Yeah, get rid of that negative 4. So this is pi is cosine inverse of x. Good so far. Now, now we're trying to get x alone. He's buried in the toaster here. So I got to get him out of the toaster. So inverse function. See, now it's fine to do that at this point, even though I didn't want to do it earlier, cosine of the left, cosine of the right, these will cancel, because I'm not distributing now. Now there's not two things. See, up here, there were two separate things. I didn't want to do it at that point, because you can't distribute cosine, as we just saw. Or any function, for that matter. Because it's not multiplication. All right, so what do we have here? Cosine pi is just x, huh? What's cosine pi? Yeah. Cosine pi, here's pi. Cosine sine, negative 1. X is negative 1. So that's a negative 1 there. We're done. Is that good? Question?